Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. I am Rajaram from Mechanical Engineering, IIT Kharagpur. We are covering module 1 in which we are on lecture number 5, Introduction to Engineering Drawing. Our course textbooks are Engineering Drawing by N.D. Bhatt and others. In lecture 1 to 4, we have learned about engineering drawing introduction, drawing instruments, the typical lettering style to be used, standard layouts of drawing sheet, few issues on dimensioning. In today's lecture, we will learn some more things about dimensioning, especially on special topics like if these are arcs, circles, curves, how to give parallel kind of dimensions and many other things. To briefly summarize you from the last classes, dimension is used to represent size and position. And a dimension is a numerical value expressed in appropriate units. In our SI metric units, we use mm as numerical value for the dimension, and this is the main communication to machinists in the production facility. We learned something about linear dimensions, how to give angular dimensions, if it is radius, and what are reference dimensions. First one, to summarize you again in terms of numerics, dimension here for an object of this shape, this one what we have shown as 1.75 as the basic dimension, and there is a dimension line to represent the line. If it is minimum 10 mm, then only we will show it in that side. If it is less than that, we use other dimension from away like that. If to represent any dimensions, we require extension lines, and if there are any curves, we represent it by a radius line, and the extension line for this radius to represent something like diameter or radius, that line what we call leader lines. For any diameters, we use special symbol phi. To represent something like a center, we use center line by dash, small dash and long dash lines. If those are not up to scale, then usually we represent those dimensions. With respect to any reference, we use a reference dimensions within parenthesis. Usually on our drawing sheets, we mention a word, sentence, unless otherwise specified, all dimensions are in mm. Instead of writing every time mm, we use all dimensions are in mm as a standard text. We went with a standard example where we have shown for an object to represent dimensions, we use the extension lines, smallest dimensions inside and largest dimensions outside. So, this is the smallest one, that is the reason inside of that geometry near to that, and the large one outside of that geometry. Is a standard practice not to show any dimension inside the object. Similarly, if these are cylindrical objects, we went ahead and showed the major diameters outside of the object through the symbol phi. So, here it is one cylinder, a step 1, and again we have a step 1. So, smallest dimensions inside and largest dimensions outside. We usually do not show anything inside of the object, that is a wrong way of showing the dimensions. Using angles, coordinates also, we have shown the dimensions, something like if there is an inclined object with respect to coordinate system, this one 2.5 and this extreme point again through our extension lines at 4 units. And similarly, extension lines using that this point, one can really show it something like 1 unit. So, once we know these points in terms of lengths, we know where to join this line. This is the way one can really construct these inclined lines. If it is angular informations, we usually represent it in terms of angles. Any chamfers we represent including that chamfering lens, using these continuous lines. Note that the dimension is outside because the gap is too small. So, it is not a good idea to show it in this way, this is wrong. It facilitates us to show these small dimensions from outside. And also there is a chamfering happened for this machining process. So, which will be 45 degrees angle. If those are arcs at single positions, we usually, this is the arc, and using dimension line, leader line, we will be in a position to represent the units. R for radius, 6 units of that. Similarly, something like this arc is there, and from here we are going to measure that arc, but using leader lines we will be in a position to represent the small units. We usually do not show it here inside the object. Similarly, if there are any intricate shapes, we encircle the area of interest and then show it as enlarged views with clear cut dimensions. Then we have tried to look at different rules for this drawing lines, some of them about size, position, how to represent them, and for example, if there are any diameters, how to represent them. So, here size represents S symbol and positions location. So, we represent it by Ls. This is size and this is location. The hole is at that particular location. Now, we will come to special issues on dimensioning. There are different ways of dimensioning these lines. One of them is called chain dimensioning. It is used when each single dimension is placed directly adjacent to the next dimension without any gap. For example, let us take this object. There is a step block, it has few holes also. So, whenever there are holes, circles and so on, we usually represent by these dash dot lines. Now, we would like to use chain dimensioning. If you are noticing here, extension line here, there is one more extension line, there is one more extension line. In between that, we are going to show dimension 20. Again this one is 25 and again this one 28. There is no gap between these extension lines. Next to each other we are showing dimensions through these dimension lines, arrows. Similarly, for the vertical direction, let us use other color. These are the extension lines, and in that we use dimension line, again dimension line here and also here dimension line. So, there is no gap in between them. This kind of next to each other, if we are showing at the same level, such kind of things what we call chain dimensioning. This method we can use it only if tolerance accumulation is not going to affect the function of the part. These tolerance issues in the next class we will learn about it. Instead of 25 mm, if we have plus or minus 0.1 mm kind of units, this extra thing what we call tolerances. That means, when you are machining or perhaps making a part or producing this kind of parts, it is not easy to produce precisely at 25 mm. There always be plus or minus kind of corrections involved. Such kind of things are called tolerances. More details we will learn it in the next class. When we do not have such kind of tolerances, then only we will be in a position to show chain dimensioning. Otherwise, what will happen? This supposed to be 25 plus or minus, that means there always be some kind of gap. So, a continuous chain dimensioning is not possible when such kind of layers exist between the parts. It unnecessarily confuses the machinists. So, we use chain dimensioning only when such tolerances accumulation is not possible. If that is not there, then only we should go with chain dimensioning, this kind of continuous thing. Let us take a cylindrical object. This one. Here, representing chain dimension, instead of that we go with parallel dimensioning, so that there always be a reference base. Let us look at through highlighter. This is the reference base. From that reference base, we are going to have such kind of dimension 15 units. Similarly, from that reference base, this one is at 30 units. Similarly, from this reference base, we have it 45 units. So, with this reference, it is quite easy to represent up to which length, up to which length, up to which length, that kind of thing, especially if we are showing it, if we are showing this one, this one, this one, look at this, these are parallel with each other. Such kind of dimensions what we call parallel dimensioning. When numbers of dimensions are measured in the same direction from a common feature, here the common feature is this, that is surface of the part, then method of indicating all the dimensions from the same feature is called parallel dimensioning. Note that the dimension lines are parallel to each other and equally spaced. This gap will be one and the same. Such kind of dimensioning is called parallel dimensioning. There is one more way of dimensioning these things called combined dimensioning. Let us pick this object. This is the object. These are the extension lines, this one also extension line, this one also extension line. Now, let us note this one, this one, this one. These dimension lines represents for this extension line to that one, from this extension line to this one, from this extension line to this one. So, these are parallel, these are a kind of continuous chain dimensioning. If you are noting 20, 15, 20 next to each other and is a continuous chain dimensioning. Let us look at other ones. This to this and this to this. When we are looking at this 8 mm and this 8 mm are in parallel with this, parallel with that. So, we have both the parallel for these 8 parts, parallel dimensioning, and for this 20 chain kind of part. Both are included in the same drawing. Such kind of things are called combined dimensioning. Sometimes it is necessary to combine the chain and parallel dimensions, for that purpose we use it. Sometimes we might require to use dimensioning by coordinates also. It is easier to read when the part would have many dimensions. Let us consider an example of using coordinates would be for a plate that has many holes in it. Let us look at that plate. This is the plate. There are many holes of different sizes. Now, if someone would like to start showing the dimensions, it becomes bit clumsy. It becomes very clumsy. So, it is not a good idea to really show all these dimensions around that object. Instead of that, it is a common practice to tabulate the things, something like this, giving names for this hole 1. Whenever hole is there, we always have this dash dot kind of lines. You see this dash 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 dash, that indicates that there is a hole. It is more like drilling a hole through rectangular plate. Here we have different holes 1, 2, 3, 4, perhaps 5, 6 and so on so stuff 11. In total 11 holes are there for this box. So, when we are not interested to represent this rectangular plate, but holes and their location, usually we go with this kind of tagging. You just give the name 1, 2, 3 kind of names, tag what we call, and its x coordinates is y coordinates. So, for x, for y, for 1 1 it is at 15 units and it is at 25 units. Perhaps in the x direction, here we know x direction, it is the y direction, in the x direction 15 units. So, if we are seeing this one is 15 units, and if we are looking at that, this one is 25 units. This is the way we understand this 15 and 25. The center of that hole is at that 15 and 25 units, and the size, basically diameter we usually represent. So, this entire diameter, if we are going to show it by leader line, 5, 10 units. Similarly, for the other holes like 2 is this one, again 15 units. That is the reason we have this x dimension 15, and it is at a longer distance in y direction. So, that is 65 for the second hole, and the diameter is 10 for that. Let us look at bigger one, 8. So, let us look at this hole, the dimensions, and understand that this part is 8. This is the hole with dash dot lines. It is at a unit of 60 units in the x direction, 50 units in the vertical direction. 50, I am sorry, this is 50 units, and it has a diameter of 15 units if we are showing by diameter. Similarly, let us pick 11th part here. In the horizontal direction, it is at 90 units and this is at 20 units. So, instead of showing all these dimensions, which becomes bit clumsy, usually we go with a tag table. This kind of thing is called dimensioning by coordinates. Similarly, whenever circular features are there, there are different ways of showing diameter. Let us pick an example. First thing, a circle, if it is a circle, it should be dimensioned by giving its diameter instead of radius. Only for arcs we use radius. For any kind of circles, we have to go with diameter dimensioning. Let us pick this circle. Because this gap is large, one can really show it in terms of arrow, a leader line with phi 30. Usually, these leader lines we keep it horizontal. This is the way. And next to it, we show the phi symbol diameter represents and the dimensioning. That is one way of showing the things. Let us look at other dimensioning. For example, this is another circle. For this circle, these are the extension lines. One can also show it in terms of phi 30 units. This is another way. If we have hole and other things, we usually go with this dash dot kind of things, or a circle with holes also we will be in a position to show this dash dot lines. There is other way of showing this dimension. Instead of showing this dimension line double arrows thing, one can also show it by a single arrow, a leader line with phi 7.5. So, this way also represents that there is a circle and the diameter is 7.5 units. There are variety of circular features we usually see it. If it is something like a circle, planar thing, we represent by diameter phi. Sometimes we see hump kind of shapes, curves, circular radius curves, that kind of thing we only represent because it is not a circle, it is just a hump and it has a radius. So, perhaps this is the center, from there it might be at r 5 units. So, instead of showing within the dimensions within the object, we usually show it in that way. For this kind of curves, arcs, it is necessary to show that center also. From that center, if we are measuring the radius, we usually go with that. If it is something like cylindrical objects and diameter we would like to show, instead of showing within the object, this is wrong practice. So, what we do is we go ahead from the object where rectangular dimensions are visible or views, because a cylinder, if we are looking from one of the view like this side, it behaves like or it looks like a rectangle. These views we will learn in the later lectures. For that dimensions we have to show it, it is phi is 6 millimeters of dimension. So, a circle should be dimensioned by giving its diameter instead of radius is must. There are many holes, they are aligned in circles. Let us look at, there is a circle, there is another circle, there is another circle and so on. There are n number of circles. In that case, we really mention how many circles are present and along which main circle they were placed. So, usually we represent that main circle diameter through leader line and also center to center distance between these circles, because they are uniformly spaced. In that case, we just represent number of holes. Otherwise, one can really show angle made by that circle, the radius connecting center of that circle to other peripheral circle. What is that angle also we usually mention. For example, let us look at this drawing. Here there are circles. The main object is this, on which these circular holes are created. Whenever these holes are there, it is common practice for us to show it by dash dot kind of lines, and they are placed around this circle. So, again dash dot kind of curve we have shown. These smaller holes 1, 2, 3 are placed around that. So, naturally we are going to show that dimension, it is some 60 units, and this circle with horizontal is placed at 18 degrees. Perhaps this circle, the radial location, that is placed at 30 degrees, perhaps this radial location it is placed at 15 degrees. Such kind of things we usually show. And one more thing one has to notice, 3 holes, 1, 2, 3 holes we are showing. Something about diameter of that hole, perhaps this one is that 10 units. Remaining things we will learn when we are going to learn about other dimensioning. Similarly, whenever there are arcs, for this arc we usually represent it by radius and center of that. Similarly, there is center of this circle. For example, this is another arc. From this center, if I am measuring that, it is of 10 units and symbol is R, because we do not use inside of the object. So, we usually show that radius from outside through reader line with 10 units and center of that arc is this 10 plus sign. Similarly, there are exterior kind of curves from here. The center of the arc is not somewhere inside the object, somewhere outside. So, with respect to that we show 46 units. This radius is made from this center. Similarly, one has to be careful here, because we have this exterior object, there should be a reference dimension, something like this is 95 units from the object, from this center to this one is 95. Similarly, the reference is this center is at 80 mm from this. This is the way we show it. In today's class, we have learned about these special dimensions for dimensioning of objects. In the next class, we will learn more about tolerances. Thank you very much.